Hey Siri, battle stations. Good morning, good morning, good morning. All right. Starting to settle back into doing this work. Feeling good about stuff. You know, it was a distracting day yesterday, but I'm feeling like we're gonna get more done today, so I'm excited about that. And yeah, let's just jump in. Let's just do stuff. Let's make things happen. So we'll start off with your typical. This guy, go through today. Let's stop this. Okay, so this is where we left off yesterday. We were working on WebRTC. So today we will do a rose thorn bud. Oops, standard eraser. What's going on? Okay, we will do a rose thorn bud. We won't do emergency QNAP hacking. We did that, but we'll check in on the QNAP. We'll check in on it. Just make sure it's doing okay. I don't know what happened to this station, but let's... Uh-oh. Uh-oh. Oh, no. Okay. This one's gone. Okay, well, let's see where this goes. Hello, hello. All right, so we'll do Roast on Burn, QNAP check-in, WebRTC refactoring, and then FinanceKit. And I may not even finish the WebRTC refactoring, you know, because I'm kind of excited to get into FinanceKit and get into some iOS stuff. So, we'll see. Play it by ear. Oh, well, we need, we're forgetting a friend. Need our friend. Get him going. Her. I need to put that like on a button on my Stream Deck. Good morning, Bobby. Oh, yeah. I have to say, hey, Bobby, good morning. Ah. More work needs to go into this bot. We need a hybrid mode. Hey, Bobby. Good morning.
Good morning, Captain Repetition. What's on the agenda today? More tinkering with the Dream Deck, or are we diving into some new chaos?
New chaos. No, same kind of chaos, but not. I don't know what a Dream Deck is, but not that. Okay. Let's do a Rose Thorn Bud. This one. Erase all this stuff. Erase all this stuff. There we go. Okay, so Rose, yesterday I was like on and off the stream because I had a phone call I had to do. I did my exit interview with my former employer. That was sort of typical. That experience. I'll leave it at that. I mean, the person's nice enough. She means well. She's trying to do well, but it's like, I'll leave it at that. And then I had an electrician come. We have a sub panel in our garage that powers our EV charger. And the EV charger kept flipping the breaker in the house that powers the sub panel. And then I would flip it back and it would come back up for a bit and then it would flip it again. And I did things like change the amount of current that the EV charger can draw, lowering it till it was relatively stable, but then it got bad again. So then I went back to flip the breaker and I noticed that breaker was very hot. I said, "Ooh, not gonna mess with that anymore." Called the electrician. They came out. It was bad breaker. Changed the breaker. It was very nice. It is a 125 amp breaker that powers the sub panel, which is only 50 amps. And I still don't quite understand. It has to do, I think, with the cable length. It's a very long run, so maybe there just has to be a lot more current. I don't know. I don't know enough about electricity. Yeah, maybe it's like you have to push enough current to keep the voltage from dropping. I don't know, something. Anyway, I think it's something like that. So yeah, that had to get replaced because it's 125 amps. It's not something you can just like have in the truck. So he's like, I'm gonna have to order this thing. It might take a week. Oh crap! I can't charge the car. But then he went out and got one. He found the place that had one and went out and got one and came back and installed it. So that was cool. He was like super nice. I was super happy. So I'm gonna say, nice electrician. Yeah, that was good. First day of school went well for Wyatt. We did have some difficulties. I won't go into the difficulties with the kid, but I'm just going to say kid difficulties under Thorn. That was rough yesterday. We've all been there. Not really any other Thorns, I don't think. Oh, the other Thorn was, and this may impact the stream a bit today, which is, we got up real early. Up too early. Like 3:30. Yikes. That's a big yikes. Bud. I am I would say FinanceKit. I'm excited about it, but I'm also nervous about it. That could turn into a rose. It could turn into a thorn. Maybe a little bit of both. So that's today. Let's go back to our... So that's our rose thorn bud for the day. Check. Great. Let's go look at the QNAP. What's going on over there? What's going on over there? The QNAP with the memory. Right? And we don't need Bobby Bot to be up on the screen. Hey, Bobby, you want to tell me a joke? Apparently
Sure,
not.
here's one for you. Why did the Scarecrow win an award? Because he was outstanding in his field. Face with tears of joy.
Face with tears of joy. Hey, Bobby, I think I've heard that one before.
Well, you know, not all jokes are gonna be winners. Just like not all streams start at a reasonable hour. 3:30? Yikes. Maybe I need to tell you a bedtime story next time.
Hey, Bobby, what kind of bedtime story would you tell?
Oh, I'd probably go with something classic, like Goodnight Moon but with a twist. Goodnight keyboard, goodnight mouse, goodnight viewers quietly clicking in the house, you know, something to remind you of the stream life.
Yeah, Bobby, that's pretty good. Thank you.
No problem, just trying to keep things interesting around here. So what's next on the agenda? More WebRTC fun, or do you need someone to blame for those early mornings? I hear the sun's always up for a good roasting.
All right. All right, so what we're going to do, go into our Ubuntu. Be a little bigger. So what we have this thing, the QNAP thing, writing here. And we're going to tail this log. We're going to tail -n100 of this log. All right. So what we've got is still MySQL running at about... I don't know what this number is. I don't know if it's like megabytes. Anyway, it doesn't seem too terribly unreasonable. I can say that, and perhaps the way we could figure out whether or not something is running away with memory is just compare the two highest. If one of the two highest is way higher than the other one, then you're like, oh, bad news. But this all looks, you know, they're all about the same, more or less. So I think we're okay on memory. So we'll check on it again tomorrow. That's an easy check mark. That one was easy. Boom. Easy peas. We'll keep this up. We'll keep this up because what we're going to do... where do we keep these? Where do I keep this? Now I'm like... There we go. We need that guy anyway. Okay. Bring this guy back up. Here we are. Right back where we were at. So my hope is I got him as soon as I could this morning because I knew that I had very little sleep and that once I get tired, my brain will stop braining and then I'll stop talking to you, all none of you, and I won't get much done. So trying to get done, trying to get going right away. haven't even had breakfast yet. All right, so where we left off is I'm gonna put some comments in here so I can do a better job of keeping track. And I probably should do like this whole thing, but I'm just gonna do this thing. So this abstracts the peer connection and ICE candidates to collect and abstracts peer connection and ICE candidates to period. Collects ICE candidates until a timeout, a threshold timeout is reached. And then triggers a pseudo event to indicate having a full collection. And that pseudo event is called on ICE complete. Okay. This is actually, so, okay, so we've got the ICE candidate stuff here. So ICE candidate says this thing where it says register the candidates. I'm registering them. Let's put some comments in here so we can see what's going on. When ICE candidates come in, we restart a timer. When the timer goes off, we assume no more candidates are coming and fire the ICE complete pseudo event. Okay. This is dispatches pseudo events. Registers handlers for pseudo events. I'm sure there's like an official way to do this these days, but this is fine. It's not much code, right? Like, just get it done. And then I'm not going to call this register track because we're not doing the same kind of thing, right? So what we're going to do here is actually dispatch track. And this is dispatch state change. Okay. And there are going to be handlers for track and state change. Okay. Great. Coming together. Feels good. Feels good. I like it. So dispatch track. Dispatch the track. Now in here, on track, we get two pieces of information from the event, right? One is the track, clearly, and the other is an array of streams. And I want to understand this better. So we're going to look up MDN peer connection on track. Okay. What is in here is the streams, an array of media stream objects, each representing one of the media streams to which the added track belongs. By default, the array is empty, indicating a streamless track. Okay? Now, why would there be more than one stream? Array of media stream objects, one for each of the streams that comprise the track being added to the peer connection. But why would there be more than one? A media stream interface of the Media Capture and Streams API represents a stream of media content. A stream consists of several tracks, such as video or audio tracks. Each track is specified as an instance of media stream track. Now, media stream track. Media stream track, a content hint. String may be used by the web application to provide a hint as to what type of content the track contains to guide how it should be treated by API consumers. Allowable values depend on media stream kind property. Want to give me some examples? Capabilities. So I'm the only reason why I think, maybe Bobby knows. Maybe I should ask Bobby. But the only reason I can think of why you would have multiple streams associated with a track event is to have streams of different qualities. You might have one that's like a, full megabit stream. You might have one that's a much less. Encoding rate is much less than that. Maybe you're on, you've got streams for mobile and streams for low bandwidth and things like this. See track event types. Track event types. The track event. The track event is sent to the RTC peer connection when a new track has been added to the connection. Each time the track event is delivered to the on-track handler, the new media is completed negotiation for a specific RTC RTP receiver, which is specified for the event's receiver property. Well, what do you do? The RTP receiver interface of the API manages the reception and decoding of data for a media stream track on an RTC peer connection. Why? Okay. Whoa. This is interesting. An RTC RTP script transform is used to insert a transform stream running in a worker thread into the receiver pipeline, allowing stream transformations to be applied to incoming encoded video and audio frames. Does that mean I can send a transform and it's run on the remote end? What is this? The transform stream interface of the Streams API represents a concrete implementation of the pipe chain transform stream concept. May be passed to the pipe through method. Transform a stream of data into one format into another. That's super interesting. That is very, very interesting. I think the music needs to go down just a touch. Okay. Okay. Well, I think for now, streams 0 will suffice. Still have not seen a convincing... This is why you might find 3 streams associated with this track event. Still have not found that. Hey Bobby, in WebRTC, is there a reason why a track event would have multiple streams associated with it?
Sounds like you're diving deep into the whole WebRTC thing. What do you need help with?
Triggered too soon. Hey Bobby, why would a track event have multiple streams associated with it?
Oh, jumping the gun there, hi. Nice save. Well, a track event can have multiple streams associated with it if the sender has added the same track to multiple streams. This allows for more complex scenarios where a single media track needs to be shared among various media streams. For instance, you might want to show the same video feed in different contexts or layouts on the receiving end. It's all about flexibility and how you want to handle your media streams.
Doesn't make sense to me, but okay. Making shit up, Bobby. All right. Okay. Well, let's just continue. You don't need to know the answer. So, and I don't even think this piece matters. The track kind is video. But what we're going to do is pass the track and the events, and the track and the streams to the pseudo event. So we will say this.dispatch track. Oh, and dispatch does not have any way of passing along stuff. Just call this object. Something super generic. Oh, okay. Okay. That should be fine. That should be fine. Think about it for a second. Now the music's too quiet. Okay. This is getting lengthy, so we will... Where are we going to break this? I think right here. Okay. I mean, we could just pass along the whole thing, right? Like, I don't need to, like, hide shit. Okay. And honestly, if I'm just like forwarding these things along, then why am I even doing this, right? I mean, there could be some reason for me to get in the middle or even just logging. So let me think about this for a minute. So a couple things. I could just keep doing it this way and just like have a pass through. Or I could try to like just have a handler registration thing. That's broken. Because the register takes an event name and a handler, right? So this should be nice, complete. All right, well, let's just keep going. On state change. Okay. And these are super tight, so let's just do this. I don't know if I do it all on one line, it's less gross, right? I want all my groceries in one bag. Okay. So we need dispatch state as well. Dispatch state change. Let's just do this. Dispatch state change. I actually do not want this at one line because I do want to be able to add a logging thing. These. Here. Okay, that looks better. All right, dispatch change this dispatch state change. Just pass the thing through. Okay. Let's take a look at what happens over here on state change. Okay. Oh, my goodness. It's a big yawn. See, it's already happening. It's already happening. Okay. Handle connection established. And this is like... Let's find that. Handle connection established. Yeah, okay. So that's higher level. So we'll leave it at this. So these are now ST connection. ST connection. Whoa. Okay. Okay, so now I've created the connection. I need to set up the listener, right? And then when I get the offer from the key, then I can, when I get the offer, I go through the motions, I'll get another event, then I'll get the stream on the on track, and then I can do the things. So I need on ice complete. When I get ice complete, one of two things have happened. I've either created an offer and now I've got the ice candidates from that offer that are to be associated with that offer, and I have to send that over signaling channel. Or I already got an offer and I need to create, and I've created an answer, and now I have the candidates and I need to send that answer. So no matter what, I need to send the offer or answer that I've already created. I need to send my local description and set of ice candidates over to the other side. So send local description. Okay. And I can include the ICE candidates. In here, I'm going to have like a method that will give me the candidates and the local description. And I'm going to call this something different because I don't even necessarily need to know. I just need to say send connection info to the other side. And over here, right, I need to get connection info. Okay. And there's going to have to be more to this, like creating offers and stuff, but let's just say return this dot PC. Oh, let's call this description. This dot PC. Oh, nope. PC local description. And this is going to be ICE. This dot piece. This dot ICE. That's just an array, right? Okay, very good. All right, we're gonna try something real quick because I got a BRB. So I think what's gonna happen, I'm gonna switch over to the BRB scene. I got new BRB scene, but I think the music is still gonna play. And I got two musics going, so that's not good. All right, be right back.
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, sitting in for Gary Kildall this week as Herb Lechner of SRI. Herb, we think of chess as the ultimate game of skill, a game that requires mental agility, intelligence, if you will. Yet here I am playing a game of chess with a computer, which is analyzing board positions and applying a certain kind of intelligence to figure out what its next move should be. That's the subject of our program today, artificial intelligence. And in some people's minds, AI suggests attempting to duplicate the way a human brain works. Is that what AI is, in fact?
Not in most modern AI research, Stuart. Early research in AI looked at duplicating human thought processes, but current AI research is more concerned with duplicating the end result of intelligence. And computers that act as experts in expert systems, and computers that can communicate with us in our language, understanding some of the context of that language, are two areas that are receiving a lot of attention in artificial intelligence research today.
Okay, we're going to meet two of the world's foremost experts on artificial intelligence, and we'll take a look at two fascinating examples of expert systems. One of the leading experts on expert systems is Dr. Edward Feigenbaum of Stanford University. We asked Professor Feigenbaum about the evolution of artificial intelligence.
The computers, as you know, are general symbol processing devices capable of manipulating any kinds of symbols, of which numbers constitute one important class, but computers are much more general than that. We've known about the generality of computation since at least the time of Turing in the 1930s, and actually I've tracked it back to intuitions that Babbage had that were reported by Ada Lovelace, after whom the Ada programming language is named. In 1842, Ada Lovelace wrote that the analytical engine of Babbage's constituted the link between the mechanical world and the world of the most abstract concepts. That currently, in the modern terminology, is called the physical symbol system hypothesis and is the basis for artificial intelligence work. In artificial intelligence as a science, we talk about the use of computers to process symbolic knowledge using logical inference methods, symbolic inference methods. In other words, we're talking about inference and not calculation in the traditional sense. We're talking about knowledge and not numbers in the traditional sense.
A current application of inferential knowledge engineering is in the field of expert systems. Programs like this oil exploration advisor. Developed to assist drilling rigs in remote areas, the program behaves much like a qualified specialist. It asks questions of its user and then gives advice on how to avoid or correct accidents so common in drilling operations. If at some point in the line of questioning the user becomes confused by the query, he can ask the program to explain itself, simply by entering why. The advisor responds with a specific source behind the question and explains its reasoning up to that point. The symbolic processing behind the human-like talents of this program have found applications in a broad range of fields, from medicine to robotics. Perhaps the most difficult area for AI to master has been natural language, a talent that results in very friendly computers, but that requires enormous processing capacity. The ambiguities of syntax and context have restricted present systems to very limited applications. A simple geographic question, depending on the phrasing, can lead to multiple interpretations. The program will determine the question's most likely meaning only after an exhaustive deconstruction of the sentence, and might even reject an unusual phrasing of the same query. In a parallel development, investing AI programs with linguistic ability has led to an interactive study of graphic communication. In this experiment, the visual dynamics of communication form the foundation for a linguistic expert advisor capable not only of discerning visual patterns, but also acting as a kind of tutor. One interactive application has given persons without normal speech the ability to adapt or construct alternative symbolic languages, a remarkable instance of using a computer program's intelligence to help interpret human intelligence. Joining us now is Jeffrey Perrone. Jeffrey's a management consultant involved in expert systems for micros, and Niels.
Nice. Sorry to break you away from that riveting content about expert systems. Okay, so we got a track, right? Start input media, this stream. Oh, wait. Ah, look at this. Okay, right. Now I remember. So now I can just say, this stream is equal to EV streams 0. Great. And about that. And I'll come back to this. Okay. Okay. Very good. All right, let's see what happens next. So what we need to do is implement this send connection info. And to do that, and in fact, so there's a couple more things we need to do, right? So this does that, right? Start input connection, start input media. So this doesn't actually start the input connection because we need to start listening for the event change. And that's going to get us into like our peer selection and all that kind of stuff. So it's going to get interesting. So we need a listen for events guy. Does it say sync? I don't even think it says sync. Great. Start listening. Song kind of reminds me of this game I played. What's it called? Alone in the Dark? That game was fun. Like a twin stick, sort of Metroidvania, all black and white. Such a weird game. It was great. Anyway. Distracted. Okay, so listening. Yes, we are listening. Gross. Okay, so we're going to call this var. I don't like the way it does this. It gives you a callback. Stop listening. Stop listen callback. Listen to under this, there's going to be, this is listening to the whole signals collection, and I want to listen to a collection, so I think I'm going to go like, you know what, I'm going to say, get collection ref. collection, signals, doc, key, collection, peers. Rather than call this signals, I'm going to call this like streams. These are effectively streams. These are like, yeah. So this get collection ref key on snapshot, right? Snapshot. Then doc changes for each. Okay. Water's good. Okay. Let's keep talking here. So what we're going to do here is, so we've got a collection of peers, right? And so what we should trigger here is an on peer added, right? And I should add, and I should have what's in the peer information. Peer will have connection info. Okay. I'm going to call this send peer info. And then in here, I'm going to have data, right? Data equals, and that's, where did data is this? Huh. Okay. Oh, fine. Bar data equals, and actually we don't even need that. Change doc data. Okay. So this receive peer info change doc data. Okay. Getting there. So now we've got send peer info, and we have receive peer info, peer. Okay. So this, what do we call this thing? In. Oh. Interesting. Okay. Here's a question. Let's think about this for a second. So each kind of connection we have, at some point we're going to have to send its peer info over to the list of peers. And it's going to get real messy, right? If you think about it. All right, let's think about this because it's going to get messy. So I need to pull this over here. Okay. We need a new page. This is a new page kind of thing. Okay. All right, so. Okay. So I'm going to make a little thing over here. Super straight line there. My microphone stand is like right in the middle of my view when I'm looking at my tablet. It's kind of annoying. Maybe can I move this over here? I mean, I don't actually need to have it plugged in. I could just do this, right? Plug it in again when I'm done. But I do want to be able to talk while I'm doing this, so this is kind of tricky. Okay, that's a bit better. Okay. So I've got here, not you. So I've got, we're going to just say this is the originator, right? So I'm going to make him like this, and he's peer 1. So peer 1 is going to add peer 1 offer, an offer to the thing, right? And then peer 2 jumps on. Okay. And this makes this connection. So now in here, in the signaling channel, I've got P2, and that has an answer. Now, P2 wants to make sure that someone else can join. Now, interesting question. Should there always be an offer like in there ready to go, and then just a new peer picks up that offer? Or does a new peer come on and say, hey, can someone help me? And then all the peers say, sure, here's the thing. I think that's more complicated. I think what makes more sense is P2 creates the answer that establishes the connection. Now P1 says, okay, my available offer is now not available. It's being used. So I'm going to create another offer. And peer 2 is going to say, hey, I'm also going to create an offer. Now peer 3 comes along, and he has 2 offers to choose from. So there needs to be some state to these offers, or they need to come back out. What I was doing before is just deleting them. But I think for tracking and monitoring, I may want to like keep these things up. And just look for ones that aren't being used, that are available. So then we will need a way to update it. So now I'm starting to think we need yet another class, another thing that's just a thing that tracks the peer state. But let's finish what we're doing here, and then we'll come back to that. Okay? So then this becomes, oops. This becomes connected. Oops, I don't want that. This becomes connected. Hey, stop it. And this becomes connected. And these are, let's put them in the state of available. Call that A. So peer 3, through some means, right now maybe we'll make it random, right? Just picks one of the available, or maybe it's based on like how many other, whichever one is the least number of connections. Getting complicated already. But peer 3 picks another one, and let's say he picks peer 2. Okay. So then you have peer 3 has created an answer. Now, who's this answer for? So we need to know who it's for, too. Getting complicated. Okay. So now we need answers need to have who they're for. Let's state. So this needs to be an answer to P1. And P3's answer is to P2. Oh. Okay. And this is pending. Now we establish that connection. So this becomes, oops, connected. No! Jerk. Connected. And this becomes, no. Bless it. There's like a tap thing for the pencil, where I can like tap it and it'll switch between erase and draw, and it only does it when I don't want it. Okay, so now that's connected, right? And now we want another. So now P2 says, I've got a new offer that's available. And P3 says, I have an offer that's available. Okay. Okay. let's see how this works. So I do think we're going to need like kind of an abstraction. And let me think about this, because if I'm a new peer, the only time I need to receive an event, I have two cases where I need to know events. One is when I originally connect. First thing I do is I need to know what available offers are there. And then I can do a peer selection, determine the offer I want to accept, send an answer. And that should effectively establish my connection if I'm this new peer. I then need to create a new offer, put it out there. And then the only time I need, again, an event is if an answer to my offer comes through. And then I need to do that other part of the handshake. So there's just an initial event. So that for peers. Peer events. Init. And answer. Those are the only two events I really care about. And the answer has to be to me. So the init event should just send, here are peers. Here's the peers that you could connect to. And maybe eventually it just sends like, here is the peer you are connecting to, because I've already done the homework to figure out which one's the right one for you. But figure that out later. Peer selection. That's going to be interesting and fun. And then here's an answer that you need to deal with. Those are the two events that we need. So I think abstracting this is a good idea. More and more, I think this is a good idea. And we're just going to have like a peers. ST peers. And so this thing isn't even going to know about the database. It doesn't give a flying F about the database. It's just going to get peers. Okay. So we got ST peers. It's going to have the database. Its constructor takes the database. And it's going to take a channel. I'm going to call this channel now. Key of stream channel. Key of the stream peers are connected to channel. Okay. And we're just going to go ahead and be subscribed to it, right? And what we're going to have in here is a local version of the peers. And then when we get new info, then we can update that. Does that even matter? So I need to know who I am in terms of peer. I need to have like an identifier. Ooh, this is tricky. Hey Bobby, what's the best way to get a UUID in JavaScript? What's happening? Hey Barbie. Hey Bobby, what's the best way to get a UUID in JavaScript?
Oh, now you remember I exist. Well, for generating a UUID in JavaScript, you can use the UUID library. Just install it with npm install UUID and then JavaScript. Const v4, UUID v4 equals require, UUID. Const my UUID equals UID4. Console.log, my UUID. Or if you're feeling like living on the edge, you can do it without any libraries using this little snippet. JavaScript. Function generate UUID. Return xxxxxxx4xxxxxxxxxxxxxxxxxxxxxxxxxxx dot replace /xy/g.
That's super weird. All right. Well, that was not helpful, but okay. Thank you. Okay. One of my dogs is not cooperating, so I'm going to have to go help bring her inside in a minute. Okay, so do we want ST peers to know who we are? Or is that... Well, if we want ST peers to only trigger an event, when it impacts me, this peer, then yes, right? The identifier of the unique identifier of this peer. Okay. Generate UUID in browser. Wait, I just... Go back. Look. Gee, where'd you get that one from? Okay. Aha. Self-crypto random UUID. Web API's crypto random UUID. Assuming that's super helpful. Okay. baseline widely available. Okay. Give me a browser. Can I just have blank? About blank. Inspect. Console. Crypto. Fantastic.
Wow. That's fantastic, Pee-wee. Thanks!
I love that. C equals new crypto? Illegal constructor. Okay. Crypto. Crypto. Illegal constructor. Bro, can you just like help me out here, bud? Random UUID. Okay. Random UUID. Random UUID. Come on, bud. Okay. Can you, friend, show me like how this works, please? This is not helpful. The crypto is available in Windows using the window crypto property, and in workers using the worker global script. Okay, so fine, good. Okay, so if I just say window crypto, oh, random UUID, bro. Friendo. I feel like I'm taking crazy pills. Am I taking the crazy pills? Oh, I need to add that one. We could do it right now. Hang on. Let's just do it right now because it'd be fun. I feel like I'm taking crazy pills, YouTube. Oh, you know, I'll just take that whole thing. So, it's like this guy. Dude, can you not be an ass? Quit unmounting that, please. How many seconds is that? Just put, okay. Okay. Clips.
Anyone notice this? I feel like I'm taking crazy pills. Anyone notice?
Okay, okay. I feel like I'm taking crazy pills. Okay. Very good. quick detour. Crazy pills. I feel like I'm taking crazy pills. Okay. I feel like I'm taking crazy pills.
Doesn't anyone notice this? I feel like I'm taking crazy pills!
Great. Great. Very good. Okay. Oh, right. Where were we? Window. No. Dot. And what is in here? There's nothing in here. Okay, what's in this prototype? Get random values, but that's it? Window crypto get random values. At least one argument is required. At least give me one. A typed array. So, like, baseline winding value. Okay, but, like, why isn't this working? Secure context. This feature is only available in secure contexts. What a dick. Why? Why? So, like, I gotta do my debugging in SSL to localhost now? That's super annoying. All right, localhost and file. Okay. Okay, fine. Okay, fine. What an asshole. Okay, but we know it's there. That's good. I don't trust it though, you know? So we're gonna have to like do some hackery. Some hackery. Okay. So over here, who should make this ID? I kind of feel like this thing should just make the ID. I don't think this thing cares. Let's just do that for now. If this becomes a problem, I will fix it. Okay? Yeah. Yep. Yep. Okay. Very good. Starting to get a little bit sleepy. Little bit sleepy. This coffee does nothing.
My eyes, the goggles do nothing.
Okay. So immediately we're going to subscribe, right? We're going to get call ref. How we do get? Is that how we do get? It is not. It is not. Look at this. Why do we need that? Can I pass something to a getter? I'm just gonna call this the ref. Get the ref. Get the ref. Return this DB collection. Is it collection or collections? Let's go back here. Collection. I rename it again. Channels. Not streams. And then doc. This channel. And then collection peers. Yes, yes. This ref on Snappy Shot. Snappy Shot. The snappiest Snappy Shot. Okay. Something's messed up. Why are you mad? Why are you mad about it? Oh, yeah. Fine. Okay. What is in snapshot? So, all right. So to trigger the initialization event, I do just need addeds, right? Because the first time we call this, everything's going to be showing up as added. And to trigger the response to an answer, that will also be just an added. So I only need an added for the actual events. Now, if I want to keep a local copy of the whole set of peers, then I would need to do something different if I want to keep that copy up to date. But I don't know that I care. So this will get called once when we first start listening, and that snapshot will contain everything. So I don't need to trigger I don't need to like figure out, I don't need to like set a timer and say, oh, stop getting things. I just need to say like, hey, if this is the first time, then I can trigger the initialization event. I've got all the data. I can trigger the initialization event. So I do need to save the data somewhere so I can do that. Okay. So let's take a look at snapshot again. I want to take a look at this. I'd like to actually see the reference to this. I kind of want to get away from looking at these examples. Reference. Web. Query snapshot. Okay. 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 Okie dokie 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 dokie. Yikes, buddy. Oh yeah, I forgot about the dog. I gotta go deal with the dog. Alright, I'm gonna take another break. Maybe refill this coffee. I don't know if there's still any coffee left, but we'll see about that. Haven't had anything to eat today. Maybe eat something real quick. Go deal with the dog. And then we'll come back to this.
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Did he? No. We knew that was going to happen. Welcome to the Computer Chronicles. I'm Stuart Chaffee. Sitting in for Gary Kildall this week is Herb Lechner of SRI. Herb, we think of chess as the ultimate game of skill, a game that requires mental agility, intelligence, if you will. Yet here I am playing a game of chess with a computer, which is analyzing board positions and applying a certain kind of intelligence to figure out what its next move should be. That's the subject of our program today, artificial intelligence. And in some people's minds, AI suggests attempting to duplicate the way a human brain works. Is that what AI is, in fact?
Not in most modern AI research, Stuart. Early research in AI looked at duplicating human thought processes, but current AI research is more concerned with duplicating the end result of intelligence. And computers that act as experts in expert systems, and computers that can communicate with us in our language, understanding some of the context of that language, are two areas that are receiving a lot of attention in artificial intelligence research today.
Okay, we're going to meet two of the world's foremost experts on artificial intelligence, and we'll take a look at two fascinating examples of expert systems. One of the leading experts on expert systems is Dr. Edward Feigenbaum of Stanford University. We asked Professor Feigenbaum about the evolution of artificial intelligence.
The computers, as you know, are general symbol processing devices capable of manipulating any kinds of symbols, of which numbers constitute one important class, but computers are much more general than that. We've known about the generality of computation since at least the time of Turing in the 1930s, and actually I've tracked it back to intuitions that Babbage had that were reported by Ada Lovelace, after whom the Ada programming language is named. In 1842, Ada Lovelace wrote that the analytical engine of Babbage's constituted the link between the mechanical world and the world of the most abstract concepts. That currently, in the modern terminology, is called the physical symbol system hypothesis and is the basis for artificial intelligence work. In artificial intelligence as a science, we talk about the use of computers to process symbolic knowledge using logical inference methods, symbolic inference methods. In other words, we're talking about inference and not calculation in the traditional sense. We're talking about knowledge and not numbers in the traditional sense.
A current application of inferential knowledge engineering is in the field of expert systems. Programs like this Oil Exploration Advisor. Developed to assist drilling rigs in remote areas, the program behaves much like a qualified specialist. It asks questions of its user and then gives advice on how to avoid or correct accidents so common in drilling operations. If at some point in the line of questioning the user becomes confused by the query, he can ask the program to explain itself, simply by entering why. The advisor responds with a specific source behind the question and explains its reasoning up to that point. The symbolic processing behind the human-like talents of this program have found applications in a broad range of fields, from medicine to robotics. Perhaps the most difficult area for AI to master has been natural language, a talent that results in very friendly computers, but that requires enormous processing capacity. The ambiguities of syntax and context have restricted present systems to very limited applications. A simple geographic question, depending on the phrasing, can lead to multiple interpretations. The program will determine the question's most likely meaning only after an exhaustive deconstruction of the sentence, and might even reject an unusual phrasing of the same query. In a parallel development, investing AI programs with linguistic ability has led to an interactive study of graphic communication. In this experiment, the visual dynamics of communication form the foundation for a linguistic expert advisor capable not only of discerning visual patterns, but also acting as a kind of tutor. One interactive application has given persons without normal speech the ability to adapt or construct alternative symbolic languages, a remarkable instance of using a computer program's intelligence to help interpret human intelligence. Joining us now is Jeffrey Perrone. Jeffrey's a management consultant involved in expert systems for micros, and Niels Nielsen, director of the Artificial Intelligence Center at SRI International. Herb.
Nils, could you kind of help us scope the field of artificial intelligence as it exists today?
Well, I'll try, Herb. It's a broad field. If you ask many of different people what constitutes artificial intelligence, I think you'd get a lot of different answers. For me, I think it concerns mainly the putting of knowledge into computer programs, so that the programs then can solve certain problems which humans find somewhat easy, or perhaps intellectual challenges sometimes. And the knowledge that one puts in is knowledge that's represented in a particular sort of way.
So the idea is that it's just not smarter programs that do artificial intelligence programming. It is some difference in techniques that they use relative to what ordinary programmers.
Well, there's a part of computer science that artificial intelligence is concerned with that does, in fact, involve a certain body of techniques that are a little different, perhaps, than what goes on in the rest of computer science.
Jeffrey, Niels is involved in the research end of AI, and you're involved in some of the applications. Are we at the point today where we can apply AI?
Absolutely, Stuart.
And in what ways?
Well, I feel that artificial intelligence, and specifically expert systems or knowledge-based systems, now are applicable any place that specialized knowledge is used routinely to reach decisions, troubleshooting strategies, diagnoses, those areas. So I kind of think of it as something where we've reached a watershed where it is no longer very expensive or very difficult for individuals with no technical background to build systems and apply them usefully.
Yeah, bro?
And you distribute a system which is an expert system and also helps one build expert systems. Is that correct?
Right. Well, actually, it's a tool for generating particular expert systems applications in virtually any area where there is that routine use of special knowledge.
And it runs on microcomputers.
Right. It runs on the IBM personal computer and a number of other compatible microcomputers.
Do you use the same techniques in this system that Nils was referring to, or used in systems that might run on larger equipment?
It uses some of the same ideas, and it has its own unique approach as well. One of the specific areas where this is a different sort of program is that instead of requiring explicit statement of rules to build a system, it only requires examples of previous decisions, previous tasks.
Oh. I have to turn that off. My eyes, they're going to go through nothing. I'm sorry you guys missed out on that awesome demo of expert systems. All right, so Okay. I'm thinking. Let's think out loud. So, so this loop here where we go through the doc changes and check for ones that are added, what we can do is just say like, hey, is this message to my peer ID? Because then we need to respond to that. That's an event that we need to trigger. And we're going to end up replicating this pattern. And I don't know that I want to do that. I'd rather have like, at least look into whether or not. There's already like an event dispatcher thing. All right, so if it's an ad, I don't like first time flags. You know what I mean? Okay. I don't know what we're going to call this. Now this is an ad. So let's say I'm a peer and I've got already 2 outbound connections and I'm adding a third outbound connection, and that third outbound connection sends an answer. An answer will be an ad change, and the other connections, they may switch from pending to, you know, established, but that's not an ad, that's a change. So we should be okay with just this. And this would only ever be an answer, right? Because they offer, if I'm a peer and I'm looking to establish my inbound connection, then the offer will be something I deal with in it. So this is only ever an answer. Okay. Now, what I want to look for now, because this is like just like placeholder, I think. What I want to look for now is, ooh, that's bright. Event dispatcher. This is not what I want. Eyedropper API. Okay, now I'm getting off track, but creating an eyedropper tool, users can sample colors. Oh, that's cool. I want like custom events. There's no like custom events API. There's nothing like event. Features available in WebWorkers. Okay. Does that mean this is available only in WebWorkers? Or it's also? No, this is the normal event thing. How do I create custom events? Yeah, this is like available version 1. Creating and triggering custom events. Event. Okay, create a new event build. Add event listener for build. Dispatch event. Event target. Okay. Okay. So element in this case is okay. So event target. So I need to be able to say that my classes are event targets. What am I building today? I'm still working on the WebRTC refactor. And specifically, right now I've abstracted the peer connection, the WebRTC peer connection, and ICE connection candidates. And now I am abstracting the set of peers. And what I have in this drawing up in the corner is logic around how we manage peer selection and the events associated with peer selection. Now I have like a pseudo event pattern that I've done here, and I'm looking at how to make this less pseudo and more proper event target and custom event handling. So WebRTC is a peer-to-peer, mostly intended for audio-video connection, but also can send just raw data, and allows web browsers to connect directly with each other, assuming that they have some kind of communication channel that they share. So Peer 1 says, hey, I'm offering to connect. Peer 2 and sends that to like a shared channel, and then Peer 2 picks that up and says, here's my answer back through this shared channel, and then the two peers connect directly to each other. What I'm attempting to do with it is use it for broadcasting. So a peer connects with a streamer, starts streaming, they connect with some number of audience. That audience then rebroadcasts that video back out to further audience. And so in this diagram here, peer-to-peer Twitch, yeah, basically. And so in this diagram, what we're describing is the idea that Peer 1, who's the initial streamer, creates an offer. Peer 2 answers it, connects to it, creates its. They both create new offers. Peer 3 comes along, connects to Peer 2, and then they both create new offers. And how that would all work. That's the idea. So what I was looking for is, what I want this, are you targeting a specific audience? No, not yet. I mean, this is just beyond proof of concept. I mean, as a business, I think people who wanted to take more control over their stream, be able to do their own monetization, perhaps people who wanted to have live streams outside of sort of the Twitch, YouTube ecosystem could potentially be relevant. And for sort of upstarts, like maybe this is a new Twitch competitor and it has significantly reduced bandwidth costs because it's all peer-to-peer. There's also a potential to tie it to sort of Web3 and distributed crypto-based stuff, and then I think that's where it gets kind of interesting, where you can start to get into things like paying out token to people who restream a bunch, using that token to feed back into the streamer as sort of bits, that sort of thing. So I think you could do that with this. Yes, there's no reason why peers who are part of the audience can't also participate. They can't also create a peer that feeds into the rest. Now it gets a lot more complicated because then you have to feed that back. But maybe it's like there's a side channel loop back to the original streamer. One idea I had a long time ago that I never implemented was the idea of a Twitch game show, where you would have side channel WebRTC. Audience members could go, it's like think Price is Right. You select 2 audience members, they come on down, they go to a special website, they establish WebRTC connection back to the streamer. That allows them to show off their screen, and then they can do something like play a retro game versus each other kind of thing. And then that's the game show. The streamer is the game show host. That would be pretty fun. And we could do that with this tech. So that's what I'm working on. Okay, so where I was at, what I want to do is, yeah, no problem, happy to. What I want to do is, I need to make my class inherit from event target. Custom class inherited from event target in JavaScript. I don't know if this is... Don't want to create a document fragment. I don't want an element associated with it. That's dumb. Event target is now constructible, so just extend it. Very good. Okay. Okay. Extends event target. Very good. In the constructor, I call super. Excellent. And now I can take this stuff out. I'm exploring peer-to-peer because a couple things. Yeah, I think the biggest barrier to entry for somebody coming in and competing with Twitch, and this is unique to live streaming. You can't do this with like YouTube. You couldn't do this for YouTube, right? Because on demand, you don't have audience all on the same time. So peer-to-peer doesn't really work that well, right? Unless you like time video starts with people, and I don't think people are going to want to do that. But in both cases, though, the biggest barrier to entry for any new entrant is bandwidth costs. I mean, besides people, but bandwidth costs are, going back to my days when I was CTO of Blip, bandwidth costs were massive part of the bill, right? Like, you have revenue sharing, that's the biggest cost, but then the next biggest is bandwidth. And if you're in a platform where you're not doing necessarily revenue sharing, but you're doing some kind of crypto thing where, you might have like an equivalent to gas fees, and then you've effectively eliminated the bandwidth costs, then the economics are like radically different. Okay, so now I can call dispatch because I can call dispatch event. So I can create an event. Okay. So these I don't need to use, because I can just add event listener. I wonder what it costs Twitch to dynamically inject ads that can't be blocked directly into the streams. Real-time transcoding. Thousands of users can't be cheap. Well, that's a good question. Are you sure that's what they're doing? I kind of feel like it's happening in the player, right? Like the player is just switching your stream over to the ad stream, and you know that's how you have subs not get ads. They don't have like parallel streams. The ad player's just managing it. That's how when we did pre-rolls and mid-rolls and things like that at Blip, it was all just like juggling a bunch of videos. And that's how it still works on YouTube. And all that like YouTube is still progressive download. It's not like real streaming. You know, like you do a standard offset web request, and you have a list of like where the keyframes are, and you say like, oh, give me this file starting from this byte, and that's a keyframe, and then it like knows how to add the appropriate amount of header, and then just starts on that new keyframe, and then that's how you jump to the middle before you've downloaded it. Okay, where was I? Okay, I'm still gonna have this like done like this, but what I'm gonna do this time is EV equals new custom event, and the name is track, and I'm going to pass along the one I had from before, and then yeah, and I should give it a new name, but it's fine. And then now, because I can call dispatch event, and with that. And you know what? Let's just do it like this. Let's just do it like this. This will make it less kind of icky. Okay. Yeah, that's good. Okay. Well, they may be serving the ads. That's a good point. Yeah, I don't know enough about current state of ad blocking technology. But it could be that they're serving the ads from the same place. So it's very difficult to determine which is an ad and which is not. But they could, I mean, they could be doing it in real time. I mean, I really wouldn't. Because presumably you would already have, so they already have to, you know, you're sending a stream. Presumably they're re-encoding that stream. Maybe they're not. Maybe they're just passing it straight on through. It seems a little dicey, but maybe they're doing it. Maybe they're not. But presumably the ads are, like, you know, pre-encoded. And again, it's just some, you know, a stream is just a set of keyframes and some deltas from those keyframes. And so they could just like add a keyframe, say, okay, here's your new keyframe, the ad and your new deltas from there. We just change what you're looking at. That would work. Either way. I don't know too much about RTMP and how that works under the hood, but I do know from the blip days that's how progressive download worked, was just stitching a header onto the offset where a keyframe starts, for sure. Okay, so now we've done this. I don't think we need register anymore, right? We're not. Yeah, we don't need this, and we don't need this. Looks cleaner. Okay, so now stpierce is also extends event target. And we are also going to super in here. Cool. So now here we can say dispatch event new custom event init. And here we can say this dispatch event new custom event answer. Whoop. Whoop. And in this case, we should send the data. And in this case, we should send, and what we should do is not just straight up dispatch this. We should filter the snapshot for offers that are available. And we should send that list of offers, and then it should choose it. So that's what we need to do next. What I want is a function that I can pass my screen through and block any ads that show up with a black box or some latest meme. That's a good question. As a backup? Yeah. Well, the question I would ask is, does the player, whether or not it's stitched into the stream or not, does the player know when it's playing an ad? Like, do the controls change? Does the pause button go disabled? I don't know. But if the player knows, then presumably you could, do some kind of... It'd be nice to add just a fast ad detect function so it just works with pixels. So it doesn't even matter. Like if you're on some, let's say Twitch is, let's do a thought experiment. Let's say Twitch is injecting the ads directly into the stream. And so then subscribers get one stream and non-subscribers get another stream. And you take the non-subscriber stream and you've got it totally outside of the Twitch ecosystem. You're just using something that can take an RTMP stream and play it. And what you want to do is, just based on the video data alone, detect whether or not it's an ad and then blank it. That's tough. I think that would be very challenging. Oh, so you're not even looking at, you're just looking at screen pixels. That's even more harder. I don't know how you would do that one. That's a tough one. Yeah. I mean, yeah. I mean, the way I guess I would do that is it would almost be like the way spam blocking used to work, where you have a fingerprint of the ad. And, you know, let's say you fingerprint like the first 5 seconds of every ad or the first second of every ad. But then it's very easy to trick it, right? Like it'd be very easy for like, you know, if they're real time stitching a stream together, I'm just gonna put some random crap or even just like watermark, you know, it'd be very easy to like undo your work. But before that happened, yeah, if you had a database of fingerprints and you're like, okay, well, this is the State Farm ad. It's, you know, 30 seconds. So 30 seconds of blank. Start. But I think if you really wanted to do that, the easiest thing for you to do would be do like a DOM injection of JavaScript. So like a Grease Monkey style script that interrogates the player. And if the player knows it's playing an ad, which I'm betting it does, it almost certainly does, and I'm sure the page knows too, then you make your change. And you may even be able to say like, you know, the ad's done, you know. Giving up on browser. All right. Well, that's a tough one. Fingerprinting, though, there is some good stuff on fingerprinting. I mean, it's something I've already looked at for this project. And there is some, even on Wikipedia, some good, like, documentation on fingerprinting. Where was this document? Here's this one. Oh, you gotta go to work. Okay. Fun. Bye. All right, back to this. Okay, so we've got our events. Oh, right. So I've got this new list of documents. So what I want is like all of the data. No, but I want it filtered. Right. That's where we were at. New customer event. Okay. Like, I'm just wondering. I think I might like switch gears soon because it's already 10:30. I've already been on for 2.5 hours, and I might switch gears into FinanceKit stuff because I haven't done that. Oh wow. Okay. Okay. But let's finish what I'm doing here. So, and it's a little tough because this is like, I'm refactoring it I'm refactoring it so hard. This is a pretty hard break. And so I don't have like, you know, like I know the data model is going to change and how is it going to change. And let's make sure that we match that. And I haven't documented a new data model anywhere. So I'm going to go back over here. An array of all the documents in the query snapshot. Docs. Okay. Oh, I can enumerate here. Okay. Okay, so I can just call for each on the snapshot. So whereas before, you know, I'm doing it on doc changes, I can do it on... Okay. So what we're going to do... Oh, and this is like kind of getting unwieldy, isn't it? This is getting too unwieldy. Sure. We're going to create a new thing called dispatch. Offers. No, we're going to call a thing called filter offers. Docs. Docs for each. For each. Doc. Okay. And then var data equals doc data. Right? And then and then so let's actually, you know what, we're gonna over here, we're gonna put up here data model. Each one is gonna have a description. Data model. Peer local description of offer or answer. And then we're going to do type offer or answer. And then ICE, array of ICE candidates. From peer ID of the sender to peer ID of the recipient. Answers only. I think that's good. Oh, one more. Status. One of ending. Established. That's it. Maybe closed. Okay. Okay. So we have our data, and what we're looking for is anything. So we're going to grab a result. bar result equals this, right? And it's going to be anything that is if data type is an offer and data status is equal pending. Now, no, I'm going to call it available. That's what we called it in our little document here. One of available, pending, established, or closed. Data, nope. Result push data. Return result. Okay. Cool, this is getting fun. This is getting good. Starting to feel like it's coming together. I feel like there's a movie or TV quote for coming together. I love it when a plan comes together. Maybe that's what I'm looking for. Yeah, I think that's what I want. All right, distraction time. I love it when a plan comes together. YouTube. No, I just want it one. And not it's supercut. Come on. Oh my god, so loud. Why are you so loud? Calm down. All right, I'll do that one with the cigar. What is that? In seconds?
Holy shit. That's not... What is that? Oh, no, that's dog's blood.
Oh, it's dog's blood. Very good. Those, I think it's more like there's 9. No, maybe it's 10 seconds. Ten seconds to 12.5 seconds. That's what I'm going to say what it is. Oh, there it is. Haha. Start is 0:10. End is 0:12.5. Or did I say 11? Let's just do 0:12.5. Oh. Paste. I love it when a plan comes together. All right, there's my clip. I love when a plan comes together. All right, so I need to go a little bit further. So it is 10.2 and a little bit less, 12.32. Nope, a little longer than that. 12.4. Oh man, it's like so super cut. It's really hard to get it to like the right thing. Okay, 12.3. Good enough. That's great. All right. I love it when a plan comes together. Okay. And then we're going to trigger that on window, U, Not you.
That's not.
I really got to fix that. That's getting annoying. So what I need to do, well, we're going to take a quick look at this. We're going to get full on distracted. Maybe we'll do this full on distraction, and then we're going to take a look at FinanceKit, and I'll come back to refactor time later. Refactoring is fun, but it also can be a little bit tedious. All right. So, comes together. Our plan comes together. I love it when a plan comes together. And we're also going to trigger it on let's try that. Coming together.
I love it when a plan comes together.
Great. Okay. Now let's quickly look at reactions. And now, do I run this in a thread? I don't think that I do. And that is the unfortunate part. Because this is not running in a thread, it makes it really hard for me to do something simple like wait a good chunk of time, like a minute, and then just make sure that I've set that scene back to disabled. That scene item, I mean. Yeah, that's a pain in the butt. To be honest, to be honest. I want to fix this right now because I don't want to keep triggering the thing, but I also don't want to like refactor this thing massively right now. I want to get back to what I was doing, but I hate leaving something broken. All right, we're going to do something gross. Quick, dirty, gross. Quick, dirty, gross. Okay. So we have this on message, and if we match, we play the reaction. play reaction, we copy the reaction, we toggle the reaction. So in here we're going to say self I want this like a reaction, hanging reaction state, right? Reset reaction on equals none. Okay. Okay. This won't be so bad. This won't be so bad. All right, so in play reaction, do we have time? We do. All right. I gotta switch brain to Python mode. Not you. I can't get now out of here. I need date time. Right? Time. Ah, that'll work. Time. Very good. Perfect. Okay. So when I play reaction, we are going to say self toggle reaction self reset reaction. Okay. Def reset reaction. Self. If self reset reaction on is not none. If time is greater than self reset reaction on. Self reset reaction on equals none. And reset reaction. Toggle 2 equals true. Self toggle reaction toggle 2 equals false. Okay. And then now this is toggle scene item. Crap it. Toggle 2 equals true. Toggle 2. Kind of gross. Kind of gross. Toggle 2. Fine. Less gross in action, but just as gross in code. Okay. Okay. Now when we play reaction, we can say self reset reaction on equals time plus I mean, it definitely won't be on for more than 30 seconds. I doubt it'll even be on for 10 seconds. Okay. Let's try it. Refusing to shut down. My cat's breath. Oh. Didn't work. Possible.
Start over. I want everything in one bag.
Yes, ma'am.
But I don't want the bag to be heavy.
Well, I don't think that's possible.
What are you, the possible police? Just do it.
Okay. Oh, I gotta keep talking. Ah, it worked. Okay, cool. All right. Hack. But it works. So let's, before we put this away, we gotta document this hack. All right. Use to trigger a reaction. Use to disable the reaction scene item after some time has passed. Because we're not using a thread here, it's a bit of a hack. When speaking happens, we check if we should reset and then set the scene item back to disabled. This prevents clips from running again when scene changes happen. All right. The rest of it should be pretty straightforward from future me. Okay, future me. You good? You good, future me? All right, we can close this. Let's get back to this. All right, so. Oh, yes, we filtered the offers. Yes, yes. Var offers equals this filter offers, and we're getting that from the snapshot docs. And the new custom event is getting offers. Okay. And we're going to say filter answers. Changes. Okay. Changes for each. And this is also going to have a result. Okay. Cool. Change. If change type is added, our data equals doc. Change doc data. If data 2 result push data. Turn result. Okay. Up. So now we can say over here, so we have dispatched the init. Our answers equals this filter answers snapshot doc changes. And now we can this dispatch event, new custom event, answer. Just say answers. No, answer. Answers. Answers. Okay. And I want this to be a little bit, even though we know that if it's added, that it's a new answer and all that kind of stuff. Let's just like make it super clear, right? So the data type is answer and 2 is me. That makes it a bit more clear. I don't need triple equals. Fuck triple equals. Come on. The type isn't the same though. Oh god, the type. Okay. Coming together.
I love it when a plan comes together.
Hey, Bobby, tell me a joke.
Why did the Scarecrow become a successful software developer? Because he was outstanding in his field.
Okay, Bobby, that's the third time you've made that Scarecrow joke. Can you tell me another one?
Oh, come on, it's a classic. Alright, how about this? Why do programmers prefer dark mode? Because light attracts bugs.
Okay, Bobby, that's better. I need hybrid conversation mode. But we're not doing that right now. Okay. So I feel like we're in a good place here. I want to go down here. And I want to change this. Because this is no longer how we're attaching to this. What we're doing now is this in add event listener. And ICE complete is the event we're looking for, right? And our handler then is this part. And let's just, rather than doing all that, add event listener track. This is add event listener. Add event listener. It's pretty cool. State change. Cool, cool, cool. Very good. All right, so all this comes back out. All this comes back out. This is all go away stuff. Go away. Oy, oy, oy. And so is this. Because now we're going to have a reference to ST peers. Okay. Well, let's put in some notes. We're right at the 3-hour mark. So this is going to go to ST peers. This is going to be peers. And am I going to take in DB and pass that along? Am I going to initialize peers outside of this and pass it into the constructor? And this needs in its constructor. Oh, what is that? Okay.
Holy shit. What is that? Oh, no, that's dog's blood.
You don't need to stop listening. So this needs to know its channel, right? I'll do like that for now. I don't love that, but okay. So let's put some notes at the top of this. All right. Where we are. We have created ST peers abstraction to manage the signaling in Firestore. We need to hook it up in StreamTooth class and right, and then need to build peer selection. Whoop. To set up create offer and answer. All right, need another break. Full of breaks today. I need another quick break, and then we're going to switch gears. So we're going to go back to today. I'm going to do a check mark for today. And then we're going to move on to FinanceKit. And I don't know how much we're going to get done on that. We might not get done much. It might be just looking at like how it works, and I haven't used my Apple developer account for a really long time, so none of it may work, and like I don't even know if I have Xcode up to date and all that kind of stuff. So there may be a lot of like housekeeping, but we're gonna get started on that and just see where we can get. And it also might be a little bit dicey, huh? Because it's financial stuff. So let's see how it goes. We'll see. We'll see. But I'll be right back, okay?
This week on the Computer Chronicles, how to build the ultimate gaming computer. We'll talk graphics cards and show you the new NVIDIA GeForce 3. We'll talk sound cards and show you how to add stunning theater-style surround sound to your games. We'll show you what it looks like to play a game on the newest Pentium 4 chip, running at a blazing 1.7 gigahertz. And the editors of Maximum PC Magazine will show us their choice for the best overall gaming computer. How to build the ultimate gaming PC, coming up next on the Computer Chronicles. Computer Chronicles is made possible in part by PC to PC, the online computer migration service from PC First, moving files, applications, and preferences from your old computer to your new one. Additional support is provided by Upside Events, presenting the Digital Lifestyle Revolution Conference, where people and technology intersect. Hi, and welcome to the Computer Chronicles. I'm Stuart Chaffee. There's some very interesting marketing data on new PC purchases, which shows that most PC upgrades for consumers are driven not by the grown-ups in the house, but by the kids who want a more powerful gaming machine. Certainly there is no more demanding application for a computer than today's graphics-intensive games. So today we are going to help you figure out how to put together the ultimate gaming computer. And we're going to start out with graphics. And here to help us do that is Tony Tomasi of NVIDIA. Hi, Tony.
Hi.
All right, so you've got the brand new GeForce 3 graphics card here, and there's a million cards out there. This is new. What is different, better? It's actually a next generation card.
That's exactly right. The GeForce 3 is the latest generation graphics processor from NVIDIA. So this product actually includes a 57 million transistor graphics processor. To put that in perspective, that's more transistors than a Pentium 4 plus a Pentium 3 put together.
Just on the graphics
Just
card.
on the graphics processor, as well as 64 megabytes of 230 megahertz DDR memory.
But what's key about this is it's programmable.
That's exactly right. For the first time, the graphics processor is as programmable as the CPU. We have an instruction set, just like the Intel processors have an instruction instruction set that you can program Microsoft Word or Windows with, we now have an instruction set that game programmers can program to create special effects on our processor.
So that means a game developer is not stuck saying, oh, I can only do what the graphics card will let me do. You can make the graphics card do whatever you want it to do.
That's exactly right. So for the first time, really, in real time, game developers can create essentially special effects.
Yeah.
And so what used to be the domain just of movies and special effects there, which are render farms and it would take hours per frame, we render those same special effects in real time at 60 frames per second.
This is all about what's on the screen. So let's get to the computer here, and I want you to show me a couple examples. First of all, in a game, I mean, you're concerned about the surfaces of things, the texture, the animation. Show us an example. You have a great example, I think, of a chameleon there.
Right. So we came up with this idea of the chameleon to really show off the nature that because it's programmable, it can change the way it looks. And so interactively, we can actually demonstrate programmability with this chameleon here. So it's completely real time. I can look at it from any camera angle, any way that I'd want. It's actually being driven.
So this is all being generated and driven right now in real time.
That's exactly right. All this
it's
code
responding to your direction.
Is running on the graphics processor in real time.
Okay. So you've wireframed it, for example?
The first thing, of course, is that the chameleon is built from geometry or wireframe. The animation of this chameleon, how he moves and walks and the skin bends over him, is done with a program. We call that a vertex shader. That's a piece of code that runs on our graphics processor that drives the way he animates. In addition to that, of course, we have the way that he looks. And so we have a variety of what we call pixel shaders to generate special effects that are on the surface of this creature. And so interactively, we can create essentially the predator look, where he's actually semi-transparent. He actually refracts the ambient light around him, and yet still reflects it, you know, or bends it into the
environment. And again, to be clear, this is no cutscene here. I mean, this is you are running this.
That's right. If you look at my hand and
you
you look at the mouse as I move it around, it's completely interactive.
Yeah.
We can play with this as we see fit. And if you look at, well, this is actually our Invisible Man shader to kind of give you an idea what the skeletal system and the vein system look like. We'll go ahead and let the chameleon continue walking here. We'll talk about some of the shaders. So as we get close, we'll go ahead and zoom in on the surface of this guy. And if you look, just say on the joints of his arm there, the bumps are correct. The way the specular highlights move across the bumps as he animates are all completely correct.
All right. Now, I want you to go to the next demonstration. Another thing in a game is the landscape, the background, the environment. They're often sort of clunky and dull, and they don't really get you into the game emotionally. And you have the ability now to actually generate real-time landscapes too, right?
That's exactly right. Because the processor is programmable, we can actually program the processor to procedurally generate a world. So the advantage here is that where previously worlds would have an end. You could get to the end of the texture or the end of the geometry, and that was it.
So again, this is a real-time generation of this landscape.
Right. If you notice the mouse as I pan it towards the edge of the screen, that's the direction that I fly, and I'm flying around the world. I can get close to the landscape. I can fly up in the air. The other nice thing about this, the world is completely generated, but we've got so much graphics processing power that we can actually have a little bit of fun. So wherever I click on the screen, we have a meteor come flying down, and the meteor does some interesting things. As he clicks and lands, you notice there's that ripple, that shockwave. We do that with a vertex shader. It's actually taking the geometry underneath and deforming it.
And again, you're running this right now. It's
on the graphics
it's not just happening.
That's
the
all
last
real
thing
time.
I want you to show us is the hardest thing in a game is the human face, right?
That's exactly
I mean,
right.
there's so much subtlety in the different expressions. Most games, the faces are pretty boring. You never get to know them, right? You have a demonstration here which is just incredible in what you can do with this card.
Yeah, we wanted to create, to solve the problem, or at least attack the problem of creating some emotional conveyance in a character. Today's game characters are kind of blockheads. They have you know, flat faces, maybe moving textures, and typically plastic hair.
So what do we
no
have
hair.
here? Zoltar.
So we've got Zoltar, which is actually kind of modeled after the Zoltar character from Tom Hanks' movie Biggs. He's a fortune teller. And it's a completely interactive face. I can view him in wireframe, or not.
Yeah, but go back. Let's see the motion around his. When he talks, I mean, you can see the skin stretch.
We'll move into his face a little bit here.
Mouth,
Get nice and close, and we'll go ahead and fire up an animation here. And you notice that what we can do is program the graphics processor to deform his actual skin. We've modeled the skeletal structure and the muscular structure of his face as programs. We download those to our graphics processor, and we can animate him and move him around entirely in real time. So for the first time in real time, you can get human characters. This is something that even the movie industry has really just started trying to tackle, and now we're running it in real time on a graphics processor.
Okay, so it's NVIDIA's GeForce 3, and it'll cost me how much?
About $399.
All right, thanks a lot.
Great, thanks a lot, Stuart.
All right, well, once you have a killer graphics card in your computer, the next most important element for a great gaming machine is sound. There are many sound cards and systems out there to choose from. Here to tell us about one high-end option is Scott McNeese of Philips. How you doing, Scott?
Great.
Okay, now we have to explain it's pretty hard to demonstrate this on television because most people are listening to some little monaural clunky speaker on a TV set probably. So they're going to have to trust us a little bit.
Right.
So let's talk about what's the big deal about your new sound card, which is what, the Acoustic Edge. Okay.
Yes.
It's a new generation card too. Why?
Yes. Well, basically what we set out to do is when you're in, how great it is if you're sitting in a movie theater with really nice Dolby Digital or DTS sound system, and you're surrounded by sound, so you just really, really get immersed in it and enjoy it. Well, we want to be able to create that same experience on the PC. The problem on the PC is most of the sounds you hear, music, even most of the sounds in games, are not positional or not 3D.
At best, it's just stereo sound, right?
Exactly. So we came up with a solution in terms of our Thunderbird Avenger chip that we developed and the algorithms that we put on it that basically allow us to take any stereo sound and create multi-channel sound, that is 4 or 5.1 channels of sound, just like in the theater, so it surrounds you.
So even though the game itself is only pushing, say, stereo sound, 2-track sound, you can somehow put an algorithm on top of that and pull that apart into 5 different channels, so I really have surround sound.
Exactly. In fact, there's 2 different cases there. There's some games that have no positional sounds at all.
Right.
And those will make that game all of a sudden a positional 3D or a surround sound game. But even those games that are coming out now that do use positional 3D, they'll only take a portion of the sounds and actually position them, and everything else will be stereo or mono.
So you can actually put more in the game than was in there in the first place,
yes,
this algorithm.
Additional layers of surround sound, if you will.
You have a nice little demonstration here, actually. If you can show us that sort of visual representation of the way you break up the sound.
Yes, this is an MP3 player that's included, and there's going to be a visual here. I'm going to start it up. And first, actually, we're going to start it in stereo. And you see these 2 little visuals here. That corresponds to a left and right speaker.
Okay, so that's the 2 tracks that are sort of pushing out the sound right now.
Right, exactly. Now, I'm going to go to
that would be our typical stereo environment.
Exactly. Now I've gone to 4 speakers, and this shows...
Now, how did you go to 4 speakers? You just told your card I want 4.
Exactly. I said, let's assume we have a 4 speaker set up with this, and let's go to 4. And if you look at this, you can see the 2 front left and right, and the left rear and right rear are very different signals, and you can actually hear it. So all of a sudden, you're hearing different sounds from every speaker.
Right.
Now we're going to take it a step further. Let's say you have a...
You said 5.1. How's the 10th of the channel?
Yeah, it's actually terminology that comes from movies, DVD and DTS. The 0.1 is a low frequency effects channel. It uses basically a subwoofer to do that. And that's that center channel right there. And this one right here is the center channel, which is also added. And that makes the vocals in a song or the vocals in a game or a movie come out very clearly from the front of you, while other sounds will come from all the different surround speakers.
All right, so we're talking about gaming here. So I want you to pull up a game just as a demonstration here. I think you have the game Forsaken up there, which is one of those games with lots of stuff going on around you, and it'd be great to have the sort of 5-dimensional sound you're talking about.
Absolutely. It's like playing with a whole new game all over again. If you've been listening to it in stereo and you listen to it this way. Yeah, this game actually came out a few years ago from Probe, and it's put out by Acclaim Entertainment. A very, very popular, very good game. Graphics were excellent. But it's a good example of a very good title, but that is stereo only.
So let me explain again. We've got 5 speakers around us here, so I mean, there's no way we can just translate that through the television set. But I mean, just go through the game and actually explain what's going on in terms of the spatialness of the action.
Okay.
You know this game?
Oh yes.
Okay. This is actually a demo. I'm not going to ask you to
This is a pre-recorded session. This is true gameplay, but it's a pre-recorded session. It's going to start up in a moment. And what would...
Right. Fascinating. Okay. All right. Now, this time, this part is going to be a little bit weird because I'm going to have to look over here. That screen. We'll see how it goes. We're going to create an iOS app. iOS 17.5 now. You will not be able to run or build your shit. I don't get it. die. All right. Downloading iOS 17.5. Great. Do that. Do just that. Do exactly that. Hey, come here, dude. Register the download. Do it. So good. We did it. Hooray. It went backwards. That progress meter went backwards, man. Okay. Can I do the thing? Okay. We're going to call this FinanceKit test. We'll do source control later. Oh, it's going to keep doing this. You know, it's very annoying when you're doing stuff like on a network attack storage. You often have these kinds of little things, and it's very annoying. Like the Xcode version. All right, so what we're going to do, we're actually going to close this project. New project. Yes. And we're going to put this. Do I have a source here? Yeah, I do. Put it here. Okay, very good. Okay. So now I need to figure out how I think I need an intent. Man, okay. I need both of these. Okay. So this is going to be a little rough because I have only done the most basic development on iOS. So we're going to be learning a lot. Great. And the way that we will do this is I think we'll toggle back and forth like this. Okay. To access someone's financial data, you must meet the criteria outlined in Getting Started with FinanceKit. Request the FinanceKit managed entitlement, hold an organization level Apple developer account, be logged in as account holder, and include the NS Financial Data Description string in your info plist. Apple reviews each application using the defined criteria. If your request meets the criteria, Apple adds the entitlement to your developer account for using managed capabilities. To request access, see the FinanceKit Managed Entitlement Request form. For more information about managed entitlements, see Provisioning with Capabilities. So does that mean, well, let's start with Getting Started with the FinanceKit. Okay. Okay, so it looks like I might need to do all of this stuff, even to just do this in like developer mode. Managed capabilities can now be enabled directly in Xcode 15. These capabilities may have one or more entitlements and are now available in signing capabilities tab in Xcode. Once enabled, new provisioning profiles for that app idea will automatically include the associated entitlements. Managed capabilities require approval from Apple to use. Once approved, capabilities can be added to your Xcode targets by program members with access to certificates, identifiers, and profiles. Okay. So I can't even touch this thing. Occasionally, entitlements may only be assigned for a subset of distribution options such as development or ad hoc. You can verify this. Okay, occasionally. Entitlements may only be assigned for a subset of distribution options, such as development or ad hoc. You can verify this by visiting Edit Your App ID Configuration section in Certificates, Identifiers, and Profiles. Many capabilities and titles require explicit app ID and aren't eligible for app clips. While you can enable all managed capabilities in Xcode, you'll be prompted to manually update your entitlements file with the correct values for some managed capabilities. Okay. Okay. Oh. Okay. Cool. All right. So is my developer program like... All right, let's see. No. All right. Account. Aha. My membership has expired again. Every time I go to do something, my membership has already been expired. So I think I need to get this app. Okay. It expired, wow, a while ago. Okay, I'm all set. Okay. Okay. Manage capabilities require approval, but once approved, capabilities can be added to your Xcode targets by program members with access to this thing. Manage capabilities and entitlements. Okay. You can enable all managed capabilities in Xcode. I don't think this is going to work. Signing and capabilities. Time is a single write granted to a particular app tool executable. Entitlements. You configure entitlements for your app by declaring capabilities for a target in Xcode. See capabilities. Okay. Signing and capabilities. Add capabilities by clicking the plus button above. Plus capability. That's unhelpful. Okay. So cannot do it. So what will need to happen I can't even look at this. Okay. I need an organization level Apple developer account. So I need a different kind of developer account. Title requests may be submitted by an account holder and are granted per bundle ID. Assigned items can only be used with the single binary associated listed in the finance category in App Store Connect and distributed through App Store or iPhone in the US. Provide financial management tools. Spending trend. Your app offers financial products, checking savings, as well as credit, debit accounts, editor, allow customers connect their financial accounts to Apple Wallet and not prohibit them from sharing their financial data with. Okay. So rude. I think this is going to be really tough for us to get. Oh, I'm looking at the wrong screen. I think this is going to be really tough for us to get. Because this kind of already assumes that, like, oh, you've got an established app. It's already up and running. It's already distributed. It's already doing a thing. So we're going to have to figure out something. All right. Well, crap, dude. Okay. Well, I'm going to go back and talk with my partner, my co-founder, figure out what the next step is here. Okay. Okay. Well, let's use this time effectively a little bit. We don't have to completely. So we're gonna back off from the idea of we're gonna do iOS stuff today. But what we can do is find out is what we want to do is we want like ultimately what I want to be able to do is get banking transaction history. And is there some kind of like third party? So banking trends action history API. Okay. Okay. Oh, hang on. I will be right back.
Most people take their fridges for granted, but life will be very different without them. Probably the earliest record of artificial cooling comes from ancient Egypt, where there are records of slaves being employed to fan earthenware pots. That was the same idea as this, the earthenware milk cooler. You put water in the dish down below, and that keeps this cover wet, and it's the evaporation of the water that cools the milk inside. The other method of cooling things, used extensively in ancient Rome, was simply to collect snow. Using a bit of insulation, it can last a surprisingly long time without melting. The Romans not only cooled their wine, but they also made ice cream. By the 19th century, various other liquids had been discovered that evaporated much faster than water, like alcohol. If I dab some on my hand, the cooling effect is quite noticeable. It's evaporating so fast, my hand's almost dry already. And this produces even more rapid evaporation. It had been discovered that various gases, when they're compressed, can condense into liquids. And in fact, this is carbon dioxide in this cylinder, and under pressure, it's actually a liquid at room temperature. If I open the valve, it'll shoot out of this pipe and evaporate very rapidly back to a gas, and the cooling effect is quite dramatic. You can see the black pipe has now gone all white because it's covered in frost. If this gas was collected and compressed again, it could be condensed back to a liquid and a sort of cycle could be established. And this is exactly the principle of the modern fridge. The liquid under pressure escapes through the restriction valve. As it evaporates to a gas, the pipes get very cold. The gas is piped back to a pump where it gets compressed and heated. The hot gas then cools and condenses back to a liquid, still under pressure. The cycle then starts all over again. The first patent for a machine like this was granted in 1834 to Jacob Perkins. At the time, Perkins' invention was not greeted with much interest because there was already a well-established natural ice industry. Ice was cut from the lakes in America on a vast scale. By 1890, it was harvesting 25 million tons a year. Britain imported over 500,000 tons, partly from America and partly from Norway. It was stored in giant wooden ice houses, where it could last all summer. This ice was delivered about twice a week by the icemen. They put it into these domestic ice boxes. The ice went in the top and the food goes in the bottom. The ice slowly melted and ended up in a drip tray which had to be emptied every day or two. Well, the natural ice industry was well established in Europe and in America, but in Australia the winters weren't really cold enough to produce much ice. In 1837, James Harrison emigrated from Glasgow to Australia. He became a journalist, but his real obsession was refrigeration.
Oh dear, I cannot concentrate, it's too hot. If only I had a wee...
Love that show. All right, what I'm going to do here. So we're going to check out plaid. Maybe plaid is the answer. Maybe plaid will do what we want. Oh. Bridges, huh? Well, there's a bridge. There's a bridge. There's a bridge. There's another one. I'm so smart about bridges. So now we're going to say, nope. Welcome to the Plaid dashboard. Let's take a tour. I love taking tours. No, I'm just kidding. I hate taking tours. But we're going to do it anyway. We're going to do it anyway. Real quick, I'm going to validate my email address. Confirm. Confirmed. Welcome back, son of a bitch. Take a tour. Customize Plaid link. Personalize messaging and configure the Plaid link experience. I don't know what Plaid link is. Grab your keys. Test out the API. Go live. Okay. I did this. Reload your page. Son of a bitch. See? I did it. Complete your risk diligence questionnaire. Get your integration off the ground by requesting access for the core Plaid API. Okay, fine. Oh. I don't want to put all this stuff in here. Not on stream. Oh my god. Oh my god, look at all this. Oh, request production access. Okay, fine. Come back to that. Okay. Learn to build with Plaid by watching our Plaid Academy tutorials on YouTube. Okay, let's do it. That's what we want. That sounds good. Dope. Happy coding. What? That all seems straightforward. There's this Plaid transactions full tutorial, but it's an hour. It's a full hour. We're not going to watch an hour video. Nice guitar guy. Oh, are they?
I like your nurse's uniform, guy.
These are OR scrubs.
Oh, are they?
Yes. Okay. Webhooks. You need two-factor authentication. Fine. Ass. No, you're a goddamn liar. Okay. Oh, I gotta do this off stream. All right. Do 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 do. Is this true?
Is this true? Yes, it's true. This man has no dick.
Yes, scan the QR codes. Stand by. No, I don't want to use. See, that's so dumb. One thing that's dumb, I think, is why does 1Password offer to be the two-factor authentication? Like, doesn't that kind of defeat the purpose? Like, shouldn't that be on a different device? Like something totally separate? Right? Why would I want that in the same place that I keep the password? That makes zero sense to me. Please explain it. Please explain that to me. I did. Oh, you're a son of a bitch. You really are. I hate you, everything you stand for. Okay? It's just... Alright, webhooks. Webhooks is an HTTP request used to provide to push notifications. AdSense webhooks automatically inform you about changes to applied items or the status of asynchronous processes. Okay, great. That's what I want. Okay. So let's go. I want to go transactions. Okay. Transactions recurring get. When transactions recurring get endpoint allows developers to receive a summary of the recurring out. No, I don't want recur. Not that kind of thing. No. What's sync? Get incremental transaction items on update. All transactions associated with an item. All right, well, let's just start with transactions get. All new implementations are encouraged to use sync rather than get. Son of a bitch. All right. Okay. All right. Okay. Very cool. Wow, there's a lot of shit in here. Holy crap, dude. Burger King. Fucking counterparties? Look at this shit. Holy moly. Wow. That's impressive. Okay. That'll work. All right, that'll work. That's what we're going to do. All right, so what we're going to do is Hello World, the Plaid API. That is what we're going to do today for the rest of the day. So we've looked at Plaid, and now we're going to Hello Plaid. That is what we're going to do for the rest of today. This will work. I'm excited about it. Let's do it. Okay. Ooh, my tummy's getting grumpy. My tummy's like, dude, it's 12 o'clock. I want food. But I've already BRB'd too much. BRB'd like 27,000 times already, so we're going to do this. We're going to quick start. Get Plaid locally by cloning the Quick Start app. You'll need API keys. You'll need them. I'm getting loopy. He's stupid. All right, go back. Ah, you son of a bitch. All right. Don't want to write code. I like writing code. Fuck you. On the API keys, you son of a bitch. All right. Clone the Quick Start repo. I don't really want to clone your Quick Start repo. Tiny Quick Start. Yeah, I want Tiny Quick Start. I don't want to do a bunch of shit. Tiny Quick Start. A minimal Quick Start demonstrating Plaid link balance OAuth. JavaScript, TypeScript, Next.js, React Native. Watch just vanilla JS. Okay, let's go back. Here's the full one. Let's go to Python. Okay. Okay. All right. Fine. VG. All right, here's what we're going to do. Inside here, we're going to clone this guy. Minutes, huh? You think minutes? I don't know. I don't know, bro. I don't think it's gonna be more than minutes. So frustrating. I mean, I don't even know what I should do about it. So, you know, I couldn't clone it onto the NAS because, well, it's like I mounted a remote volume, remote share through SMB. That is then tied back to this Windows subsystem for Linux. So it's abstracted there. And so what do I do? Like I could, I guess, like set up an NFS mount to the NAS when I'm in WSL. It's a project for another day. Don't love it. All right, here's a quick start. This is development server. Son of a bitch. Okay. Well, we're off to a great start. Okay. Serious? Oh yeah, I guess I had it minimized or something. Okay. Ah, bitch. See? What a turd burglar. Because now, how do I get to it? What a turd burglar. Hi. This is why WSL kind of is good, but kind of is not good. All right. WSL to access storage from Windows. Back on your lunch break? What's for lunch? Bagel with cream cheese. Nice. Okay. How to access your Linux files in Windows 10. That's what I want. Ah. That's gross. All right. Backslash WSL $. Okay. So what happens if we do this? What a dick. All right. Let's go here. Oh, you thought about it for a second, and then you puked. This one. I want this one. Yeah, that one. Okay. And then this one. This one. And this one. Now, what are you going to do when I do this? What you going to do about this, sir? Okay. Yeah. I'm sure that's yeah. WSL, I mean, it's cool as a concept. I will say that, but it needs more work. Okay, so look who appeared. Look who decided to stop by. All right, so I want to pin this. I'm gonna pin you. Ugh. Okay, home. You pin. And I wish I could change the name of the pin. No. God, what a dumb. What an absolute dumb. All right. Fine. You know what? And how I possibly remember that this is that? Put it there, at least. And put it up there. All right. Well, I'll know it when I click on it. Okay. Yes, trust it. Oh, I trust the shit out of it. No. Fine. Yes, I trust. Oh my God. No, shut up. Okay. Oh, yes, do it. Thought I already did that. Okay, great. Oh. Fine. Yes, I did that. Thank you. God. All right, flask. Uh-huh. Mm-hmm. This is a lot for hello. To be honest. Alright, so running on that. And so I guess I can call. You can tell I GSD. Familiar with GSD. So API info. I'll get shit done. Yes. No, I'm not an architecture astronaut. Can't connect to the server because I stopped it. Method's not allowed. Okay. So you tell me how to quick start. All right, it's quick start guide. Don't want to look at your thing. Docker, huh? I'm already annoyed at this thing, so I may just do that. I don't think I have Docker installed, but... Do you have Docker? Okay, well, putting Docker under WSL is like a horrible idea. Do you have Docker? No. Okay, fine. Let's get Docker. Let's do that. Why Docker? Because it said that's the easiest thing to do. And I'm already mucking up my system enough. So I'm at a point now where I'm like, yeah, sure. Docker sounds like a plan. This can't run on your PC. The hell? What? Why in the hell? Why? What? Hello for Windows. ARM. Well. Oh. ARM. Duh. Oh, wait. Where is, like... It's an API, but it's got like a whole heavy-handed handshake thing that they want me to use. I'm already annoyed with you. Alright. Backing up. Without Docker. so I need like this whole front end, and then I can use the back end. All right, so let's do this stupid ass thing. All right, fine. Wait, what node version do I have? It's probably like ancient history. Oh, no, that's not right. Maybe ignore their quick start. I mean, I can always come back to this, right? Like, I don't have to use this for the long term. But I also feel like I could bang my head against the wall if I am stubborn. Which I am a lot, but... let me see how this rabbit hole goes a little bit further. The goal is to kind of like get to a, hey, here's hello plaid. I can see that this is going to work, and then pick it up again tomorrow. Yeah, all right. Okay, so I did that. Let me start. Did you just open my browser, you son of a bitch? All right. Your application is running at port 3000. Oh, that's so exciting. Plaid flow begins when your user wants to connect their bank account to your app. Simulate this by clicking the button unable to fetch link token. Make sure you have your backend server running and that your .env file has been configured with your Plaid client ID and your Plaid secret. Okay. Great. And I want to close this folder. And I want to open a new folder. Yes. Fucking do it. All right, .env example. Okay. We're gonna copy, paste. I'm gonna call this, rename it .env, and then we're gonna say banner. Do not show on stream. Great. Okay. Back to work. Glad you enjoyed the bagel. Thank you for the good luck. This goes in here. Yes, move it. Do what I said. Okay. Now, the toughy part. The toughy part. We will go... Yeah, please enjoy a view of this Mac. Look at how beautiful that is. Please enjoy that. All right, my dashboard, my home. Settings. Once you have your API keys, where do I get my API keys? Signing up in the dashboard. Okay? View keys in the dashboard. Haha. Okay. Client ID. Copy. And paste. Copy. Paste. The secret. This says sandbox. Never share your secrets. Okay. I see. Very, very good. Okay. Save that. Roll up here. Okay. Okay. We can close that guy. Close that guy. And now we can switch back to this guy. Very good. Okay. Now over here. Whoa. You probably need to restart. Unable to fetch link token. Please make sure your backend server is running and that your .env file has been configured with your stuff. It has. So you're pissing me off. Dude, does that need to be in here as well? In front end? Probably. Perhaps. Okay. Let's find out. Copied. Oh. Copy .env here. Okay. And now try again. Son of a bitch. Please make sure your backend server is running and that your .env file has been. So does that mean I need to run another? This thing's complicated. Holy shit. All right, so I think what I need to be doing. Yep. All right, launch link. Plaid Quick Start uses Plaid to connect to your account. Yeah, do it. Yeah, I'm with Chase, bud. Continue to log in. First Platypus Bank. Okay. Yeah, it's checking again. I've read. Cool. Haha. Very good. Okay. This is kind of cool. See, this is kind of cool. All right. Oh, look at this. It kind of freaks me out that SparkFun is in here because this is actually something I would do. Pretty cool they put SparkFun in there. I bet you, is this place... Wait, hang on. Crunchbase, Plaid. Bet you they're Colorado. Oh, San Francisco. Surprised. Okay. Surprised. Okay. Cool. McDonald's. Okay. Okay. An item represents a login at a financial institution. We called it item. Okay. Okay. All right, so I got the quick start going. I think I'm going to cut it out here. I'm going to call that good on Hello Plaid. I think I need to do... I agree with you, Twitch TD. I think what I need to do is kind of start from scratch. But maybe what I can do is, at the very least, I can use this quick start to just like take these two pieces of information and bring them into the other app that is just going to use their API, and then I can start doing stuff. That's what I'll probably do tomorrow. So tomorrow will be more on Plaid. We're going to do some more Plaid stuff. I'm curious how we can get to the point where we can actually test with real data. I think I have to do all this stuff. Yeah. Okay. And let's look at, before we cut out on this, let's look at pricing. I mean, I guess it doesn't really matter. Okay. Very cool, very cool. Transactions. Yeah, this is what we're going to get into next time. We're going to set up a Python script to use transaction sync without a web server, just based on having the appropriate tokens. And then we're going to see what kind of stuff we can get out of it. And then what would be great is if I could like create my own sort of fake transactions. I wonder if the sandbox allows me to like modify the transactions. Okay, yeah. Though I don't see anything in here about create a transaction. Sandbox item fire webhook. Ledger deposit simulate. Okay. Simulate is deposit sweep event. What is this? Transfer event. Use the sandbox transfer simulate endpoint to simulate a transfer event in the sandbox environment. Note, while an event we're simulating will appear using endpoints transfer event sync, transfer event list, no transaction will actually take place. No, that is not. That's close to what I want. That is not what I want. But it doesn't look like there is a transaction sandbox. So we'll have to create our own, I suppose. All right. Oh. Wow. their Plaid's CRM is very good. They've already like reached out, like they saw that I used a token. They're like, "Great job, I'm your rep. You want to talk?" Pretty impressive. All right, chat. Thank you. This is a good day. I made a lot of progress today. I'll be back at it tomorrow. We're gonna dive back into more Plaid stuff. This is looking fun. We might do a little more WebRTC refactoring. We might not. What is today? Wednesday. So tomorrow will be Thursday. So yeah, I think we'll probably be focused on Plaid for the day. And I really want to get into start thinking about like, well, I got to talk to my co-founder and see how much we're willing to talk about what we're building, but I'd love to start talking about what it is and how it's going to work. This is not the WebRTC thing. This is the other thing that I've been thinking about and working on and playing around with. So yeah, we'll see you then, and have a great rest of your day.